Hello guys, welcome to another lesson in basic mechanical engineering, and in this video we will know how to design a cold water pipe, or we will determine here what is the appropriate size of the pipe that we will be using given a number or specific type of fixture. Okay, so i-compute natin kung gaano ba kalaki, kung ano ba yung diameter na dapat natin gamitin given na ganito yung mga fixture sa loob ng ating building. Now, as what you can see, this is a sample of a plumbing layout. Okay, plumbing layout, ito yung naka-attach sa plan. No, pag mag-a-apply ka ng building permit, plumbing layout should be attached as one of requirements. Okay? Now, as what you can see here in our plumbing layout, we have this blue one. This is the water supply pipe. Our water supply pipe coming from the water main. So, it goes to our fixture. And we have three different fixture here. We have lavatory, we have water closet, and we also have kitchen sink. Okay? So, given this fixture, we can compute for the water demand or the water consumption or the probable consumption of water inside our building. Actually, this is just a residential plan since we only have few fixture. So again, we have one water closet, we have also one lavatory and one kitchen sink. Now, if you measure the length of our pipe from the water main to the remote fixture, and our remote fixture is the kitchen sink. So if you measure it manually, we have approximately 9 meters length of our pipe. We will be using this length because this is also one of the considerations in designing our pipe. Okay? Now, we can compute for the water demand in our building by just referring to table 6-5. Table 6-5, this shows the fixture, type of fixture, and its equivalent water supply fixture unit. Now, we have encountered fixture unit already from our previous lesson. WSFU, or fixture unit, represents the demand of water. Okay, this is representation of how extent the fixture or how extent the demand if we will be using that fixture. Like for example, bar sink. Now we have for private use, we have 1. For public use, we have 2. Now for bathtub, we have 2 water supply fixture unit for private use, and we have 4 for public use. Now as what you can see, we have higher value for public use compared to the private use fixture unit, since we all know mas malaki yung demand sa public use. Tama? Mas marami ang gumagamit sa fixture if sa mga public CR siya. Like for example, sa mga mall, sa mga theater. So, mas marami ang gumagamit sa mga fixtures. Hence, we have higher total demand. Now, for most commonly used fixture, we have lavatory, we have 1 for private use. For public use, we have 2. For sink or dishwasher, we have 2 for private use, and we have 4 for public use. For water closet, flush tank, we have 3 for private use, and we have 5 for public use. So, we will be using this value in our design. Okay? So, again, private use and public use has different value depending on the amount of or the number of people na mag-consume sa water. Okay? Now, how are you going to convert this fixture unit into volume of water? Now, we know already that one fixture unit is equivalent to 1 cubic foot of water per minute na makonsume, or equivalent to 7.5 gallons per minute, or approximately this is equivalent to 8 gallons per minute. Okay, so this is maximum. If we use that certain fixture every minute, the maximum amount of water na pwede nating makonsume is 8 gallons or 1 cubic foot in every minute na gagamitin natin siya. This is higher value compare sa actual, tama? Since in actual, hindi naman tayo makakonsume ng 8 gallons per minute, di ba? So, basically, this is a conservative value. Ginagamit to siya in our pipe design. Okay? Ginagamit lang to siya to determine the maximum probable or to determine the minimum size that we need to apply in our piping design. Okay? Now, let's go back to the residential layout. We know that we have one water closet, and that water closet, since that is private use because that's only a residential building, so we have 3 water fixture unit, and we have also sink, which is 2 WFU, and for lavatory, we have also 1 WFU. Now, counting the number of each fixture, we have 1 for water closet, so therefore, we have total of 3 water supply fixture unit for water closet. The same as with the sink, we have 1 as well, so that is equivalent to 2, and 1 for lavatory, so we have 1 as a total number of water fixture in our lavatory. So total, we have 6 water fixture unit. Now, we know that water fixture unit is equivalent to 1 cubic foot per minute. So we multiply it by we can use 8 gallons per minute instead. So we multiply it by 8. So 6 times 8, we have 48 gallons per minute as the water demand for our building or residential building. Okay? So this is how you are going to compute for the water demand. So you just count the number of fixtures, then multiply each fixture by its equivalent water supply fixture unit. Now, in designing pipe, we need to consider a lot of factors, and that includes the pressure in our pipes. Okay? So the pressure, this is the intensity of force per square area or per unit area. Okay? The pressure of our water or the pressure that we will be using in our design is equivalent to the average pressure at the main minus the static pressure, where each P is the net pressure. Okay, since we get the difference between the average pressure and the static pressure. Now, for static pressure, this is the pressure loss due to elevation change. So, 9.79 times H, or that is the height of the most remote fixture. Kung meron kang fixture sa second floor, so you measure the vertical height, okay, of the second floor from our ground floor. So, multiply it by the unit weight of water. The unit weight of water is 9.79. Okay, that is the unit weight of water, which is 9.79 kilonewton per cubic meters, or it is approximately, pwede rin siyang 9.81 kilonewton per cubic meter. Okay, so if you multiply it by height, this we can compute for the pressure due to the change or due to the height. Actually, you will know more of this sa hydraulics or fluid mechanics natin. Okay? Now, the P average, that is the service pressure at the main. Okay? So, at the water main. So, in Davao City, water main has an average pressure of 30 to 50 psi, or approximately 345 kilopascal. Okay? So, we compute for the pressure first. Okay, then we choose the table based on the pressure ranger where the net pressure at the water meter will fall. So, going to table 6-6 at page 74. So, we have table 6-6. So, after you compute for the pressure or the net pressure, so you identify kung saan table siya ma-fall. Like, for example, we have the pressure range here. We have 207 to 310 kilopascal, or 30 to 45 psi. Now, take note, 1 psi is equivalent to 6.895 kilopascal. Okay? So, if given a psi, we can convert it to kilopascal. Okay? Now, psi here is pound per square inch. Okay, 1 pound per 1 square inch of area. Kilopascal naman, this is equivalent to kilonewton per square meter. Okay? Since Pascal is equal to Newton per square meter. Again, this is the unit of pressure. Okay, then we also have PSI, or pound per square inch. So these are the units of pressure. So again, you identify the table where our pressure will fall. So it could be from 30 to 45 PSI or 207 to 310. Pwede din siya sa 46 to 60 PSI or 317 to 413. And or if we have over 60 PSI or over 413 kilopascal. Okay? After identifying the table, select the length column which is equal to or greater than the required length. So, you measure the length of the pipe from the water main to the remote fixture. Kung ano yung pinakamahaba na pipe. From the water main to the most remote fixture. The number 3 is follow down the column to a fixture unit value equal to or greater than the total number of fixture units required by the installation. So, if we, for example, this one, if you fall to this table, now this first row here, this 12, 18, 24, 30, so this is the maximum allowable length in feet or in meters. So, you choose the next higher value sa length mo. Like, for example, if your length of the pipe is 59, so 59 will fall between 46 to 61, correct? So, you choose equal or greater than 59, which is 61. Under this column, we have these fixture units here. Okay? Then, we have, if we compute the fixture unit, so, ikuan mo siya kung saan siya magfo-fall dito, the value equal or greater than the fixture unit na na-compute mo. Like, for example, if your fixture unit na na-compute for the entire building is 24, so 24 falls between 23 to 39. Okay, so you choose 39. Then after that, you project sa row. This is the pipe size. So from 39, you project at this point. So we have 25 millimeter. That is the pipe size for our meter and street service. Or we have 32 millimeter pipe size for the building supply and branches. Okay? So this is how you are going to determine the sizes of our pipe given that we have the fixture unit or the total fixture unit and the length of our pipe. Okay? So, why don't we try to solve or to design using an example? Now, but before that, let's always remember that in building water service pipe, again service pipe, this is the pipe in between the water meter and the water main. So, if you remember my previous video, service pipe is the pipe that is connected to our water meter and to the water main. Now, for service pipe, the diameter should not be less than 19 millimeter. Okay? Now, most commonly, ang ginagamit ng mga plumbing natin is in inch. Correct? Sabi ng mga plumbing usually, 2, 4, or media, di ba? So, what is the unit of that? Now, we can also express our diameter in terms of inches. So, we have 2 inches or we have 1 inch. Now, take note, 1 inch is equivalent to 25 millimeter in SI. Ito yung most commonly conversion. Though 1 inch in exact, it is equivalent to 25.4 millimeter. But in actual, they use 25 millimeter instead. Okay? So, we have also 1 and 1/2 onomidya inch. So, this is equivalent to 38 millimeter. Or 2, we have here, we have 50 millimeters. Okay? Then, we have as well 1 and 1/4, which is equivalent to 32 millimeters. So, this is the commonly used conversion. Okay? So, let's try to solve problem. We have here, design the size of the pipe that is connected to 2 water closets, 2 lavatories, 1 kitchen sink, and 1 bathtub. And we have the length of the pipe, which is 5 meters. So we have two water closet, and we also have two lavatories, one kitchen sink, and one bathtub. You will know it obviously na private use siya since we only have few number of fixtures. So water closet, now we know from table 6-5, we have, for water closet, we have 3 water supply fixture unit. That is for private use. So in total, we have 6 water supply fixture unit. Lavatory, we have 1. So we have 2 lavatories times 1 WSFU. This gives us 2 water supply fixture unit. For kitchen sink, we have 1 times. Now, going back to table 6-5, we have here kitchen sink or dishwasher. We have 2 water supply fixture unit. So, we have 2 water supply fixture unit. So, total, we have 2 water supply fixture unit. For bathtub, we have 2 for private use. So, we have 1 times 2 water supply fixture unit. So, this gives us 2 water supply fixture units. So, you compute for the total fixture unit for the entire building. So, we have 12 water supply fixture unit. So, the water demand is equivalent to 12 times 8 gallons per minute. So, we have 96 gallons per minute ang makonsume, okay, in every minute. Okay, 96 gallon of water ang probably makonsume in every minute. Okay? Now, since we are asked to compute for the pipe size, now we need to know first the pressure in the water main, or so that we can compute for the net pressure, which we know that the net pressure is equal to P average at the water main minus the pressure of due to elevation. Okay, pressure due to elevation, or that is the static pressure. Now, we do not know yet the P average, but in Davao City, we have 30 to 50 PSI, the average pressure. So, we can use 40 na lang as the average. So, we have P is equal to 40 PSI. But since our pressure is in terms of English unit, we have 40 PSI. So, we can convert this into metric by multiplying it by 6.895. So, 1 PSI times 6.895. That is in kilopascal. So, we cancel out PSI. So, therefore, we have the value of our P average, which is equal to 275.8 kilopascal. So, this is our P average. Okay? So, we can now compute for our P using this equation. Okay? So, we have P is equal to, P average is 275.8. Now, our static pressure, that is equal to 9.79 times the H. Now, take note, since hindi sinabi sa problem if it is 2-story or 3-story building, so we assume na 1-story lang siya, and that we do not have fixtures sa taas or fixtures na naka-elevate. So, therefore, our H here is equal to 0. So, our P static here is equal to 0. Okay? So, we have our P, or we have the net pressure here equal to 275.8, since again, this, our static here is equivalent to 0. Okay? So, this is our P. Now, we locate kung saang table siya na fall. Okay, that is, remember that is 275.8 kilopascal. So, we refer to table 6-6. So, 275.8 is in between 207 to 310 kilopascal, correct? So, ito yung table na gagamitin natin. Okay, so, since the pressure range is 207 to 310. Now, we have the length of our pipe. From the problem, we have 5 meters, correct? So, 5 meters, so approximately, ang 5 meters natin is less than 12, correct? So, we choose 12 as our length sa pipe natin. Then, we identify the fixture units here. Now, the total fixture unit is equivalent to 12 WSFU or 12 water supply fixture unit. So, we have here 12. Now, 12 is in between 6 and 16. Correct? So, we choose 16 instead. Okay? Now, project sa pipe size. So, we have 19 millimeter for meter and street service, and we have 19 millimeter for building supply and branches. Ang branches dire kay maupod tong mga fixture branch, okay, mga fixture supply. So we have this as the pipe sizes for the street service pipe and the building supply and branches respectively. Okay? Now what if you fall at this value na may asterisk? Okay, like for example, the water supply fixture unit is 13. Okay, then you fall in this column. Like, let's say, for example, the length of the pipe is 22. So, 22 is in between 18 to 24. So, you choose 24 instead. Then, you identify the total water fixture unit and you found out that it is 13. So, it is in between 4 and 14. So, instead of 4, you choose 14. But take note, we have asterisk for our 14. So, do not choose value na may asterisk. Instead, you move sa second or sa higher na value. The next higher value, which is 23. So, 23 yung gagamitin mo. Okay? So, we have here, now for service pipe, we have 19 millimeters or this is 3/4 inch. And for branches, we also have 19 millimeters, which is equal to 3/4 inches. Now, again, in service pipe, the diameter should not be lesser than 19 mm, which is, this one is okay. Now, in table A-1, in page 167 of the plumbing code, we have the minimum pipe size na nakakonect sa ating individual fixture. Like, for example, for bathtub, this one, we have 13 millimeter ang minimum size ng pipe na dapat nakakonect sa bathtub. Ito yung fixture supply pipe. Diba ang fixture supply pipe, this is the fixture or the pipe that is directly connected sa fixture natin. At saka yung fixture supply pipe ay nakakonect siya sa fixture branch. So, if you don't remember, please go back to my previous module, which is the water supply system. Now, for example, in our flush tank, or water closet for flush tank, this one at the last row, we have 10 as the minimum connections for cold water. Okay? So, since obviously, hindi naman dili naman kinahalan ang hot water for our flush tank. So, cold water lang. So, 10 millimeter as the minimum pipe size na dapat nakakonect sa flush tank. And as well as for the lavatory, we have also 10. For sink, we have 13. We have already determined the value of the size sa pipe natin, which is 19 millimeter, and this are greater than the required connection sa individual fixtures, and that means that these sizes here are okay. Okay, so okay lang ang ating pipe size. Since again, this is more than the required minimum connections for our individual fixture. Okay, let's try to solve this problem. So let's go back to our plumbing layout. So we have computed this one already. We have the total water supply fixture unit, which is equal to 6 water fixture unit, correct? Or WSFU. So, ito yung total sa building na to. We have computed this one. And then, we refer to, again, table 6-6, di nata sa 6-5 since sa compute naman nato ang water supply fixture unit. So, we do not have given value of our P, so let's use again 40 PSI, or that is equivalent to 275.8 kilopascal. And then, this is only one story, so our static pressure is equivalent to 0. One-story building lang man siya. So, therefore, our net pressure is equivalent to P average, or the pressure na nasa water main, which is equivalent to 275.8 kilopascal. So, let's again go back to our table, but please remember this value, 6 water supply fixture unit, and the pressure 275.8, as well as the length. So, from our first problem, this is 9 meters, correct? If you remember, so we have this value here. So, let's go to table 6-6. So, saan siya mag-fall? So, dito pa rin mag-fall sa within 207 to 310 kilopascal. So, we have the length is 9 meters. So, therefore, we still have 12 meter as our maximum allowable length. And this, we have the fixture unit, which is 6. So, we use this 6 here, which is greater or equal to the total water supply fixture unit. But since 6 naman yung ating na-compute, so we choose the 6 value. Then, let's project to the size sa ating pipe. For meter and service pipe, we have 19 millimeter, and for building supply and branches, we have 13 millimeter. Okay? So, we have here for service pipe, which is 19 millimeter diameter, or that is 3/4 inch. And then for branches or horizontal pipe inside the building, you have 13 millimeter diameter, or 13 millimeter diameter, that is 1/4 inch na pipe. So this is how you're going to compute for the right size of pipe. And now we have here our third example. We have designed the pipe size for a 2-story commercial building having 5 water closets, which is flush tank, 5 lavatories, 2 bathtubs, 3 kitchen sinks, 10 urinals, which is flush tank, and then the story height is 3 meters, pressure in the water main is 320 kilopascal, and the length of the pipe is 27 meters. So the first thing we do here is to compute for the total water supply fixture unit. Now, let's enumerate the fixture. We have for water closet, we have 5 water closet times, now again, this is public use, so we refer to the public use column in table 6-5. Water closet flush tank is, we have here, we have 5 fixture unit, so we have 5 times 5, okay, this is WSFU. So this give us total of 25 water supply fixture unit. Then we have for lavatories, we have 5 lavatories, and for public use, lavatory has 2 water supply fixture unit. So we have 2 WSFU, which gives us 10 WSFU. Then we have also bathtubs, and then the water supply fixture unit is 4 for public use, 4 WSFU. So therefore we have 8 water supply fixture unit. Kitchen sink, we have 3 kitchen sinks, then we multiply it by its equivalent fixture unit, but still in the public use. So we have sink, dishwasher, we have for public use, we have 4. So we have 4 water supply fixture units. So we multiply, we have 12 WSFU. Then we have urinals. Let's say it's as UR. So we have 10 urinals. Again, this is still a flush tank urinal. So we multiply it by its equivalent fixture unit. So we have here urinal flush tank at number 18. So we have 3. Now, as you notice here, wala tayong fixture unit for private use kasi hindi naman siya required na may urinal sa mga bahay. Okay? So, urinal usually, ginagamit siya sa mga public comfort rooms. So, we have 3 WSFU. We have 3 WSFU. So, therefore, we have 30 water supply fixture unit. So, total, we have 85 water supply fixture unit. Okay, so this is our total water fixture unit for the entire building. Okay, so after this one, we refer to table 6-6, but our P here is equivalent to P average, or the pressure in the water main minus the P static, or the static pressure. So P here, this the net pressure, is equal to, now P average, or the pressure in the water main, is 320 kilopascal, minus the static pressure. Now the static pressure here is equivalent to 9.79 times the height of the fixture, or the elevation of the remote fixture. And since this is only 2-story and the story height is 3 meters, so we multiply it by 3. Okay? And this is in kPa. So we have the net pressure here, which is equal to 290.63 kPa. Okay, so let's go back to table 6-6. So we have our pressure here, 290.63. So 290.63 falls in this table. So in between 207 to 310 kilopascal. Okay? So we have the length of our pipe, which is 27 meters. So we proceed to this row. Okay? So saan mafo-fall ang 27? Na 27 is in between 24 and 30. So we choose the greater value, which is 30. Okay, then under the column, or under this column, we have the fixture units. Now our fixture units is equal to 85. Okay, so 85 falls between 48 to 91. So we choose 91. But if we fall to fixture unit with the asterisk on its upper right, or its superscript, so therefore we choose the next value, okay, which is 21. But since the fixture unit that we computed is 85, so we choose 91 instead. So therefore we project to this column here. So 91, so we have 38 millimeter for street service pipe and 38 millimeter for building supply and branches. Okay, so these are the pipe sizes for our street service pipe and the building supply and branches. We have for the service pipe, for the street main, we have 38 millimeters diameter, or for building supply and branches, we still have 38 millimeter diameter. And that ends this lesson. For more videos, please don't forget to subscribe to my channel and hit the notification bell. Thank you guys for listening, and see you in my next video.
Parang nenengbi ang kanyang katawan, ang sarap mong titigan. Rosas ka ba?